We're continuing to look at the CSEC Mathematics January 2024 paper. We're at question 8. It says the diagram below shows the graph of two functions on the same pair of axes. The lines G and H are perpendicular. So you have the line G and the line H. And you have the right angle triangle right here, right? Now, determine the equation representing the line G. Right, before you do anything, remember, pause the video, make an attempt to work out the question, even to work out part of the question, like part A, and then you watch that part, right? Well, it would be good if you attempt to work out the entire question. Make a genuine attempt at it before watching the video. Now, as usual, your homework, if you haven't, part of your homework is that if you haven't subscribed yet, you should subscribe to this channel and share the video with somebody else. Any questions, comments, and so on, you put it in the comment section and we go talk from there. But anyway, here, the line, equation of the line G. Alright, let's see what's going on here. We have, by the way, let me just copy this and put it over to our whiteboard, because this is where we're going to be doing our writing. Alright, now this line G, it passes through -6, x equal -6, and y equal 3. You remember that the general form of the equation of a straight line is y equals mx plus c. You remember that formula? M is the gradient and c is the y-intercept. We have the y-intercept here is 3. So far we know that y equals mx plus c. Now, we can determine the gradient. You can say it is rise over run. The rise would be 3 and the run is 6. If you're going from left to right, it will have a positive gradient. The rise is 3, the run is 6. So here you have 3 over 6. So the gradient m is rise over run 3 over 6. It's the same as 1 over 2.5. So y is equal to half x plus c. C is 3 plus 3. Alright? Now, that is one way you can find the equation. Let's also look at this. So y is equal to mx plus 3. At point 3, x is 0 and y is 3. You can see that. So if x is 0 and y is 3, 3 is equal to 0x plus 3. Good. You would have the intercept worked out here. 3 is equal to 3. But let's look at what happened here. When x is -6, y is 0. So x is -6, y is 0. So y is 0 equal -6 is m, -6 x plus 3. So you could say subtract add -6x to both sides. If you plus, or add 6x to both sides, I should say. If you plus 6x on the right and plus 6x on the left, you'd have 6x is equal to -6x plus 6x. That would go. You have 3, so x would be 3 over 6. So mx plus c, x is, what am I doing here? when you have y equals 0, x equal negative 6. My mistake, I had put the negative 6 on the x. That was a mistake. This is when x is negative 6 and y is 0. Let me do that part again. X is negative 6, y is 0. 0 is equal to m times negative 6 plus 3. That's what I should have had. Just looking at another way of doing it, because you usually have more than one ways to work it out. Alright, so you have 0 is equal to negative 6m plus 3. If we add 6m to both sides, we'd have 6m is equal to 3. So here, m, the gradient, m would be 3 over 6, which is a half. That's another way that you could have found the gradient, substituting values of x and y. But anyway, we get y equal half x plus 3 as the thing there, the equation for line G. The other equation we want is that for line H. By the way, let us look at the marks for line G. They give what? 2 marks. For H, they give 2 marks. Alright. For line H, we want the equation of line H. Now, H passes through the point when x equals 4 and y equals 0, right? And it is perpendicular to the line G. So let's use those pieces of information to see what we could get. We have the equation here of line G. Let's just label it. So that's line G, right? Now, for line H, it's the same pattern, y equal mx plus c. Now, do we know the intercept or the gradient for H? We don't know the intercept, at least not yet. But can we tell the gradient? How would you be able to tell what the gradient of line H is? Well, you'd have to remember the relationship between two lines that are perpendicular. Alright? What is the gradient when you compare them? You have to remember that when two lines are perpendicular, the gradient of one multiplied by the gradient of the line 2, gradient of line 1 times the gradient of line 2 equal negative 1. The product of their gradients is negative 1. And you also remember what happened to the gradient. What's the gradient when they are parallel? They would be the same. You have to remember those things, you know. Right? Those things are not in the formula sheet. You have to remember them. So here now, the gradient of line G. See, you can write it out in plain English if you want. So gradient is equal to a half. Now, here, gradient of G multiplied by gradient of L must be negative 1. So, half times gradient of line L. Is it L? H, line H. Times the gradient of line H must be negative 1. So what is the gradient of line H? What is it? Well, it's negative 1 over a half. But what is negative 1 over a half? It's going to be negative 2. So the gradient of line H is negative 2. So for line H, y is equal to negative 2x plus c. Alright, we need c. Your problem here is that c is not labeled. If you look up here for c, you won't find it. But you have a certain point on the line. When x is equal to 4, y is equal to 0. So let's see what happened here. Well, they put f of x instead of y, but it's still y. So x equals 4, y equals 0. Let's substitute those. Y is 0 equal negative 2 times x equals 4 plus c. So 0 is equal to negative 8 plus c. So what could c possibly be? If you add 8 to both sides, you will see that c is equal to 8. So the graph goes, it cuts at the y-axis at 8. It intersects the y-axis at 8. So the gradient of line H is y is equal to negative 2x plus 8. So that's the gradient. Alright? Now, so that's the gradient. You have the gradient of line G, gradient of line H. The coordinates of P show all working. We want to need the coordinates of P. Alright, so let's get back up here. We need to find out where P is. Now, P is where both lines intersect each other, where x and y's are the same, where they are the same right at that point. So here, what happened in this case is that both x's are equal and y's are equal. So the same y, same x. So we're going to have here y is equal to y. So if that is the case, remember, you have the two gradients, the two equations. Let us just erase some part of the board. So we have some space to work with. So for line G, y equal half x plus 3. For line H, y equal, what was it again? Negative 2x plus 8. Negative 2x plus 8. Alright, so we have this written down, so we can erase it. Now, at this point is the same y's. So you can say that y equal y. But the thing is, what about the x's? X will be equal to x2, you know. But guess what? What you have is y equal half x plus 3 and y equal negative 2x plus 8. So if y equals y, what happens? Then half x plus 3 must be equal to negative 2x plus 8. Alright? Now, let's put these things together. Let's add 2 to both sides. So if we add 2 to both sides, add 2x to both sides. Let's move these things to the right to make space. We're going to add 2x, right, to both sides of the equation. So we say plus 2x on the right and plus 2x on the left. Half of 2x plus 2x is 2.5x. So it's 2.5x plus 3 equal, well, you can see here that negative 2x plus 2x is 0. That's gone. So all you have left is 8. Right? Now, it's neater when you work with improper fractions. So Let's turn the 2.5 into improper fraction. 2 2's 4 and 1 5. 5 over 2x plus 3 equals 8. What do you do here now? To find out what x is, we're going to subtract 3 from both sides. So we minus 3 on the left, minus 3 on the right. We have 5 over 2x. 3 minus 3 is 0, so that's gone. Equal 8 minus 3 is 5. So what is x here? Well, if we divide both sides by 5 over 2, we have x is equal to 5 divided by 5 over 2. Because when we divide, 5 over 2 will cancel itself here. So we have x alone. That's why we divide by the 5 over 2, right? And then this is going to be 5 multiplied by. Remember what you do when you have a number over a fraction. You multiply by the reciprocal of a fraction. There is 2/5. They cancel down, so x is equal to 2. So x is 2 at that point. If x is 2, what is y? Here, y is half x plus 3. Let's try the line for, well, the equation for line G. Y equal half x plus 3. So if y equal half x plus 3, then y equal half times 2 plus 3. Half by 2 is 1, 3 and 1 is 4. So x equal to y equal 4. Suppose we had tried it with the equation for line H. What would happen? Y equal negative 2x plus 8. So y equal negative 2x plus 8. We would have y equal negative 2 times 2 plus 8. Negative 2 times 2 is negative 4. Negative 4 plus 8 is what? Y equal 4 again. Which is supposed to happen. It's the same x's and the same y's with both equations. So the coordinates would be x equal 2, y equal 4. So it's 2, 4. Right? So here, where is it? Oh no. The coordinates of P would be 2, 4. So remember the proper way to write coordinates is that. So you say the coordinates of P would be 2, 4. Alright. Let's see what else they have here. That's 2 marks. But it's quite a little bit of work for only 2 marks, you know. But remember we're at question 8, which is section 2. Right? In section 2, you do more work for less marks. Alright, this is part B. We'll leave part B for our next video.